Well, hello students, welcome back. It's been quite a while since I've seen you, and today we're going to start with our unit on radicals. Today we're specifically talking adding and subtracting radicals, okay? So take out your notes, pause this until you get those out. Once you get those out, start it back up, and let's get started, okay? All right, here we go. You have this square root of x. It's read the square root of x. Okay, this is just a quick review for you. This one, where instead of having the square root, it's got that 3 up there, which means it's the cube root or the third root. Okay, and this last one, since we don't have a number there where the root is, we would say it's just the nth root of x. So we could put any number there and it would just be that root of x. Okay. Let's look also at a little bit of terminology. If I have a base raised to the 1/2 power, that's just like saying it's the square root of that base, okay? That 2 is the root, and since it's a 2, we don't have to write it, and the 1 is actually the power, okay? So this one could be written as x, and I'm going to take x is to the first power, and I'm going to take the third root or cube root, or we typically just say the cube root. So those are the second one up there, and then this one would just be the nth root of x. Okay, so that's some basic terminology review for you. Okay, now again, remember when you add or subtract anything, they have to be like terms. So if it's got an x in it, it has to add something to it, that has to have an x. I can't add an x and a y together. Okay, so to add or subtract, they have to be like terms. With radicals, like terms are when the root part is exactly the same. So what that means is, if I have the square root, I can only add the square root, and what's inside of it has to be the same. So I can only add the square root of 3 to the square root of 3. If I have the square root of 3 plus the square root of 12, I can't add those together unless I simplify this one, and then I can make it the same thing underneath the radical symbol. Okay? So we're going to use that when we go through and start working these problems. Alright, so now some basic rules for the adding. The first thing we're going to do, if I've got radicals in my problem, I'm going to simplify all the radicals. And we worked on those in class, the last class period. So you should know how to do that. But we want to simplify all radicals into their lowest form. After we simplify them, then all we're going to do is we're going to collect like terms. And if things aren't like terms, I can't combine them together. It's as simple as that. So make sure you write this all in your notes. You'll have that to look back on. Okay? Now what we're going to do is we're going to go ahead and jump into working some examples. All right, our first example is 5 times the square root of 2 plus 3 times the square root of 2. Now before I can add this, I want to go through and make sure that my radicals are exactly the same. And if I look, the first term has the square root of 2, and the second term has the square root of 2 also. So these are already like terms. So what I do is I leave it the square root of 2, and I just add those coefficients, the 5 and the 3. 5 plus 3 is 8. So if I have 5 square roots of 2 and I add 3 square roots of 2, that gives me 8 square roots of 2. This is a nice basic simple one because we don't have to do any simplifying. In our next example, we will have to simplify some. So let's go ahead and try that one. I have 5 times the square root of 3 minus the square root of 12. If you'll notice, the first term is the square root of 3. The second term is the square root of 12. These are not like terms, so I cannot add them unless I can simplify one of them to where it looks like the other one. So let's look at that. The square root of 3, there's no perfect squares that go into the square root of 3, so it's simplified. So I'm going to leave it 5 times the square root of 3. Now the square root of 12, that can be rewritten as the square root of 4 times 3, which is the square root of 4 times the square root of 3. Notice we got that square root of 3. We're looking for that. The square root of 4 is a perfect square, so that's just 2. And then I have my square root of 3. So now I'm going to work, instead of writing the square root of 12, I'm going to replace it with 2 times the square root of 3, because those are equal to each other. Now if you'll notice, I do have like radicals. So I'll leave that radical, the square root of 3, and I'll subtract the 5 and the 2. So 5 minus 2 is 3. So my answer is 3 times the square root of 3. Hopefully you understood that. If you didn't understand it, rewind back and look at that example again before we move on. Okay, our third example, I have 6 times the square root of 5 minus the square root of 20. So let's look at our radical part. The square root of 5 and the square root of 20, those are not the same. So I want to see, can I simplify these at all? All right. Well, 5, there's no perfect square that divides into 5. And it's a prime number anyway, so I'm just going to have to leave it 6 times the square root of 5. Now the square root of 20, let's go over here to the side and work some notes. I want to look at the largest perfect square that goes into 20. So the largest perfect square that goes into 20 would be 4. So I could rewrite this 4 times, and then 4 times 5 is 20. So I'll rewrite it as the square root of 4 times the square root of 5. And I may be doing more steps than you need, but this is for those of you that do need the steps. If you don't need all these steps, then you don't have to write them all down. The square root of 4 is 2, and then I have square root of 5 left. So that's the simplified version. So 2 times the square root of 5 is the same thing as the square root of 20. Now I notice I have the square root of 5 and the square root of 5. So what I can do now is I can add these because they're like terms. So I'm going to bring down my square root of 5. I'm going to do 6 minus 2 is 4. And there's my answer. A simplified version is 4 times the square root of 5. Alright, easy as that. Let's do one last example. Alright, here's our last example. 5 times the square root of 12 plus 9 times the square root of 3. My first question for you, are the radicals the same? So are these like terms? And the answer is no. I have the square root of 12 and the square root of 3. So the second question for you is the square root of 12, is that one simplified, or can I simplify that? And if you said I can simplify that, you're correct. How about the square root of 3? If you said no, we can't simplify it, you're correct also. Okay, I'm going to give you a second here to see if you can go ahead and pause the video and see if you can work this one on your own. When you get it done, restart the video and I'll have the answer there for you. Okay, so here's how I worked it out. We saw that 5 times the square root of 12 simplifies down to 10 times the square root of 3. When I substituted that in for 5 times the square root of 12 and added it to 9 times the square root of 3, you got 19 times the square root of 3. Take a minute and look at how I worked that out if you didn't get it right, and hopefully you understand what you're doing. If there's any part of this video you didn't understand, go back and look at it again. Otherwise, complete the WSQ and be prepared to discuss this in class tomorrow. Hope you have a great evening, and we'll see you then.